So maybe we can start. I will do a short introduction to introduce Albert, because Albert is an old friend of the Faust Gram team, and we know Albert, I think, since 15 years or something like that, and we met at the Linux Audio Conference, I guess. And Albert is a mathematician and computer scientist working in the field of computer music and media technology. And he's a designer and the main developer of the pure language, a functional language based on term rewriting. And Albert is at the head of the Computer Music Research Group in the Institute of Art, History and Musicology at the Johannes Gutenberg University in Mainz in Germany. And he's also teaching computer music. And he's also very active, a member of the Linux audio community and a developer of many open source software. And Albert contributed a lot to the Faust project. So I guess first thing was the pattern matching system that was added in the Faust language and compiler back in 2006, maybe, doing that with Jan and taking ideas from the pure language. It was a very substantial add to the Faust language. And Albert was the organizer of the first version of the IFC 2 years ago with Romain Michon. It was done in Mainz. And Albert contributed several architecture into the system of Faust architecture, like the Faust to VST, Faust to LV2, Faust link to pure data, also doing a link between his own language pure and Faust, so that he can load Faust DSP code into the language. And he did a lot of bug fixes, improvement and suggestion to the development of Faust itself. And today, Albert is going to demonstrate one of his latest development with the PD Faust Gen 2 project, which is also using this dynamic compilation chain based on libfaust and LLVM, and which allow to do Faust-based DSP audio programming and using MIDI and OSC to control everything done in pure data. And Albert will explain how he can do DSP programming with Faust and do some live coding demos. Albert, it's up to you. Thank you.
Thank you, Stefan. Too much praise, too much praise. But thanks a lot. Thanks also to Alain for organizing the IFC under these conditions and for inviting me to speak about my favorite topics, which are PD and Faust. And this talk is this presentation is no different. I've posted when I still had a chat, I posted a link there which goes to the materials. You can find the slides there, and all the remaining links are there. And I've seen that they're also on the conference website, so you should be able to find your way while I'm getting into it. So there are the links there to PD and to Pardata, the version that I'm using here, and to PD Faust Gen 2. So I originally planned to do this workshop with the older external I had, which is called PD Faust. But I have to admit that I haven't been able to work on pure, which PD Faust is written in a while, and so it still uses a very old LLVM version, which isn't good if you want to use it alongside with other stuff that uses a newer version. Then stuff keeps crashing. So I'm slowly phasing out PD Faust now. But 2 years ago, I at LAC, Pierre Guyot who was at CICM back then, introduced me to PD Faustgen. And at the time, I couldn't really take a closer look, but I did recently. And I realized that I would be able to do most of what I can do with PD Faust with PD Faustgen, but I would have to add some new facilities to it, and that became a side project. And then suddenly I had all the features that I needed, so I can now present my workshop about learning and using Faust in PD, using PD Faustgen 2, because it's clearly the way forward now. And as I said, I'm phasing out PD Faust, so it made sense to switch the workshop to that. So there we are. Let me first, because I don't know whether everyone knows PD. Probably you've heard about Faust if you're here, but PD, aka pure data, is that interactive graphical real-time multimedia environment created by Miller Puckett from the UCSD. So he, of course, you all know Miller. He created Max back in the day at IRCAM, and then did an open source version, which had also lots of audio objects built in as soon as that became feasible on PC hardware. That was sometime in the middle of the 90s. And so it provides a modular patching environment like Max, which most media artists will probably know. But it's open source and free to download, so you don't have to pay anything. And it's therefore also well known and loved by computer musicians and media artists all over the world. And it's used a lot in teaching computer music at various places, also at the Johannes Gutenberg University, which is where I am. And it offers an abundance of objects for all things that you need for computer music. So audio, DSP stuff, control, processing, even doing graphics, 3D graphics and video. That's a bunch of stuff that's available there, and it has been available for quite some time. So it makes sense to use it as a teaching tool, because more likely than not, you will come across it if you want to work in the field of musicology and are interested in contemporary music, or if you're a musician or media artist and want to work with these tools. It's good to know this one, because Max and PD are, I'd say, they are the mothers of all modular systems that we're using today, apart from hardware, of course. So there's a separate lineage there, but if we're looking at all the software that's available, there are quite a bit of them have been influenced by these tools. So the flavor of PD that I'm going to use here is a newer one called Perdata, or PDL2org version 2, which was done by Jonathan Wilkes and is still being done by Jonathan Wilkes. I'm also involved with that project, and it's been presented at Saint-Etienne in 2017, if I remember correctly. There have been so many lacks, so I might be wrong on that. But anyway, that's still actively developed, and you could say it's the successor of PDL2org and PD Extended. There's a clear lineage there, and I'm using that. I prefer to use that in my courses because it's easier to use. It has more modern GUI. The vanilla PD, as we call it, has a GUI which is made in Tackle-TK, and that's getting a bit long in the tooth now. And so it Perdata uses web technology instead. So it's not an Electron app, but it uses something similar called not Node WebKit NWJS, if you've come across that. So basically the patch windows then become browsers, and you can do all kinds of things that you can't do in TK, like more possibilities with drawing and so on. And that makes the GUI much easier to use, which is why I'm using that here as well. So I should give a brief demo of that now. So I'm going to see whether I can just minimize this. And there we have it. That's per data. This is the main window over here. And there we have a patch window, which I've already opened in the right directory so that it will find all the stuff that I'm going to use now. But let's start off with something really simple. Let's say we want to build a little synthesizer in PD and don't want to put too much effort in it, just to show to those of you who haven't seen it before how this works. I can just start entering objects here, and there's a menu for that, but I'm going to use the shortcuts, and most of the time you need this, which creates a named object when you then have to type the name of the object. And there are also messages, numbers, and various GUI elements that you can work with. So let's start with Midi input. I want to have node input, so I'm putting a box here, and the object for that is node in. And then I can just press Control Enter, and I have that object still selected, which means if I enter the next object now, it will be connected right away. So I enter with Control 3, I enter a number object, and I want to duplicate that so that we can see what the input of node in is, or the output rather. So you see there are some formatting operations which make all this stuff simple, and I can now simply go and connect these. So whereas the patching environment in OSSIA we've just seen works from left to right, if I got that correctly, this one works from top to bottom. So like Max, it's pretty much the same thing. So I can start dragging a cable here from any outlet. That's how these things are called in PD lingo, to an inlet of an object. And if I now start typing some notes, you see the notes being printed here. So we have the MIDI channel on the right. We won't make much use of that or any use of that, so I can delete that right away so that it's less confusing. And if I play, let's say, middle C with a certain velocity, you get the velocity value here, and you get a note value here. So 60, of course, in MIDI is middle C or C4. Okay, so we know what the note is. We know how loud it's supposed to be. Okay, translating loudness, translating these velocity values to a volume in the 0-1 range isn't a big deal. We can do that right away. We divide by 127 and then we're done. So let me show the resulting value down here. And I also need to translate the MIDI to frequency, which is basic stuff, but there's a built-in object for that, which is called M2F, which translates MIDI to frequency. So let me put a number field in here too. So if I now input a middle C, you can see the normalized velocity or volume here. And then you have the frequency here. And now I just need an oscillator, which I can just connect here. Oscillator, a sine oscillator, or rather cosine oscillator, I think it's actually is called OSC. And the tilde there indicates that this is an audio object which will produce or consume audio. In this case, it will produce audio. So there we have it, and you see these black dots here in in contrast to the lighted dots here, indicate audio data. So I could, in principle, send the frequency as audio data, so at audio rate, to if I have glissandi or something like that. I'm not using that right now, so I'm just sending it a control value, but I could do that. And the audio which comes out of here is the sound. So to make we don't hear anything yet because I've not connected it to the sound card yet. But before we do that, we also want to make use of the volume value. So I'm adding another object here, which is called multiply tilde. So this then multiplies the output of the oscillator with the volume value that I get from up here. I hope you can all see this, or should I make it bigger? Is it good, Stefan?
Yes, I think it's okay, yes.
Okay, thank you. So now we have the value that the sound that should come out of it, and now I just need to connect it to a DAC object, which represents the sound card in PD, and we have 2 channels here by default, but it can be any number of channels if you have multi-channel equipment hooked up to your sound card. If your sound card is capable of producing 8 channels or 16 channels of audio, you can have all of that represented in the patch. So now I should be able to play some notes. Yeah, it doesn't sound very nice because we have we have this crackling sound because the sound gets cut off as soon as the note goes off. So the way you can deal with that is to just add an envelope, and the way you do that in PD is the simplest way is to use a message like this, which takes the value from the volume and adds a time value, like let's try 30 milliseconds, and passes that into a line object, which you probably know that even if you don't know PD, it's the same in the music languages, and C sound, for instance, and Super Collider. Of course, you have certain objects which produce envelopes, and line tilde is exactly that. It does a fade in and a fade out, and in this case, it does it with the same time value of 30. And so now, if I pass that into here, then I don't have the crackling sounds anymore because I implemented a proper envelope now. And that's a simple monophonic synthesizer in PD, that's all. So there we are. Let me go back to the slides. No, that's for later. That was the wrong icon. So we've seen PD. I really like to use that for teaching the basics of computer music because you can really get down to the nitty-gritty. And that's also something that you can do with Faust. You can go even more into the technical details of certain algorithms like reverberation or distortion, and really implement, as we've seen this morning, amp simulations and stuff like that. And you do that in a real programming language. So I don't have to introduce Faust here. You probably all already know it, and but I wanted to point out that what we're using here is the embeddable compiler, which is libfaust, and also what we're using here is the standard library of Faust, of course, where we have many amazing algorithms already. And Faust, of course, supports an abundance of different target environments, but the one that we're using here is PD. And for that, we can make good use of the LLVM backend in libfaust, which does JIT compilation. So it compiles it whenever you need to, just on the fly, which is great for an interpreted environment like PD, for instance. So highly dynamic environments. So you really want to be able to just take the Faust code and recompile it on the fly, like we've seen in OSSEA score just in the previous workshop. So we can do that in Max and PD. I think Stefan was the first one to actually implement that with the Faustgen external for Max, and Pierre Guillot ported that to PD, or a version of it. It wasn't really a port. He wrote it from scratch, and that's the version that I based my Faustgen 2 on, which is basically Pierre's Faustgen, but with lots of bells and whistles added. And before I tell you about those, I will do a quick demo of that stuff. So there we are. We can just delete this stuff now, and let me just show you a little object which comes from this little Faust source. Which you probably recognize. Jan, you should know this source. I pilfered that from the Faust documentation, but I know that Jan has been using this as a kind of hello world example for a long time. The only thing that I added here is a little slider object so that I have a control parameter for the volume of this thing. And okay, let's try it out. I can just now what I've done here is I've loaded Faustgen 2 as an external already at startup, and then I can use it as a so-called loader plugin. So it hooks into PD's loader. That's something that I think you still can't do with Max. So that you can just type the name of the Faust DSP and have it instantiated as an external. And all the JIT compilation and that kind of stuff just happens in the background. So I can now just create an object here. Control 1, and then I can just type the name of this Faust DSP file. And because these are all audio objects, you don't have to do it, but you can type the tilde so that it looks more familiar to PD programmers. And that's basically all you have to do. And then you click anywhere or press Control Enter, and there's your noise object. And if I exit the edit mode of PD, I can just click on this object and it will open the file again in your favorite text editor. That works on every platform. So there we are. So you see I have a slider here, volume. That becomes a control variable which I can modify, but let's first listen to the sound. So I'm going to leave some space here for extra stuff that I'll need later. So let's just listen to it. I need a DAC object, obviously, and then I can take this this audio output here. So the first outlet is actually a control outlet. And I've also made it so that's a change from the original Faustgen, both from the Max and from Pierre's version, is that here there's always one control inlet, and that makes stuff more symmetric and it works better. So I did it that way. That's also the way it works in PD Faust, by the way. So what we want to hear, what we want to listen to is this here. So you hear the sound now, and so you should have heard some white noise, and that comes from the Faust unit in this case. So what if I want to control the volume? I can do it the hard way. I can have, let's say I take some number input here and then turn that into a message again. And this has the form, so the volume parameter, so that's the Faust label of the controls. You need to put that there, and then the value itself. And I can pipe that into the myNoise object, into the control inlet. And then I can, if I turn Let me just enter that once, and so I can turn back the sound back on. So now it's at 0, and if I make it louder, you hear the noise again. So you have that volume control now. But this is also a new feature in FaustGen 2. You can also generate a GUI automatically, like you've seen done in OSSIA and like PD Faust does. So I don't actually need this. And I can just open a new subpatch, a one-off subpatch for the PD users among you. And then you give it some name. I'm going to name it noise now, but you can name it anything. It could be named GUI or anything. So, and then let's add this, the name of the patch that I just created. That's just an empty subpatch right now. I can just close this. And then I can just type the name of the patch here, the subpatch, and then I get the GUI generated here. And I can control this this object from here. So if I have more than one parameter, then I would have also several controls here. So that mimics what we've seen in OSSIA, this automatically generated GUI. This works here too, and it's just an ordinary PD subpatch. So if you want, you can modify that, right? Okay. There are some controls here. For instance, I can switch it back to the default value, and I can also turn the unit off or on. So there are some basic controls there, and the stuff that you need to work with this in a convenient fashion. Okay, and now, of course, the question is, how do you control this parameter by MIDI? And we have some conventions there in the Faust source. So let me open the Faust source again. If you want MIDI control in Faust, you have to augment your control definitions with some kind of metadata, which looks like this. So oops, that was the wrong key. You just type this stuff into the label, so the name of the control as it's externally visible, and you can just type something in square brackets, and the convention is for the MIDI controllers you use this designation, MIDI control, and then the controller number. I'm going to pick 7 because that's the MIDI volume controller, and that's all I have to do. And now I need to recompile the Faust external. So one way to do that is to send it a compile message. That's like in FaustGen 1 by Pierre's FaustGen. But we can also just send it to I can create a connection to my Emacs here. That's something that's very easy to do. Actually, I did this morning sometime. I created this FaustGen 2 remote, which is a variation of the Faust remote I had for PD Faust. So you have a little button there, and you can also have a shortcut here, which will let you just initiate the recompile. Let's put the main window here. So I can press Control-C, Control-X, and then it should have worked, but for some reason it doesn't. Now it works. Okay. There's some bug there. Apparently some changes in Emacs again, so I will have to look into that. But you see, it was recompiled, and now it also prints the MIDI controller that I've defined. So that happens when it recompiles, it prints some basic information. And now I just need a MIDI input, and I'm going to describe the format that's being used in a minute. But I have a little abstraction for that which does that, and I just need to hook that up to the control inlet, and now I can control the volume with my MIDI keyboard, with a knob on my MIDI keyboard. Yeah, so that's the basic stuff. We've seen a lot of the actual workflow now. So you're entering those objects, you're creating GUIs for them, you recompile them when needed. You can do any changes anytime, and it will then, if you recompile it, it will then pick up the new version, and it will also change the GUI. For instance, if I add another, let's say, what's the word? Checkbox, I think. Checkbox. Enable. I didn't try this, so this might not work now. I should have checked beforehand.
I think it's okay. Checkbox, yes.
Yeah, there was an extra multiply sign there. Okay, let's see. And you see the GUI was updated automatically, and I now have this enable button there. So if I don't actually need this because I have the activation button here, but if I now sound is still on, but you don't hear anything because I need to push enable, and then we still don't hear anything. And why is that? Demonstration effect, I don't know what happened there. So I can control the volume or just shut it down like this. Okay, so that's the way the stuff works. Basically, basic workflow. I go through the different steps in the slides later on, but that should suffice as a basic introduction to this stuff. So let's close this. And have a look at the slides again. So just a few things about PD FaustScan 2. So as I said, it's based on the CICM PD FaustScan, which was done by Pierre Guyot when he was at the CICM. And this in turn was inspired by Graham's FaustScan, so by Stefan's FaustScan for Macs. But compared to Pierre's FaustScan, it adds a lot of features. It's not entirely backward compatible, for instance, because of this one extra control inlet thing there. And so I picked a different name so that you can still run Pierre's version if you prefer, and the new version in concert. And you can get it in GitHub. So the FaustScan 2 branch, which is the new branch, is the default branch on my GitHub fork of Pierre's repository. And with these new features, I have now achieved parity with both Stefan's FaustScan and with my own PD Faust. So we have support for MIDI, we have support for polyphonic input, so different voices. We have Scala tunings, which is something which is not in Graham's FaustScan, but I'm always experimenting with tunings, and my students are also interested in that because historical tunings and stuff like that. And so I support tunings in Scala format here, and there's support for OSC, and as you've seen for the PD GUI, the PD GUI generation stuff also works, like in PD Faust. I think that Stefan, maybe you can update us on that, but I think the Max FaustScan doesn't have automatic GUI generation, or does it?
Automatic what?
Graphical, sub-patch with control elements, yeah.
Not inside the, yes, in some sense, if you use, there is a Faust2Gen script that you can use and that the first time you generate, you can have the user interface, but it does not work.
So it doesn't update automatically and all this stuff. Okay.
So it's not so convenient. Yeah.
So that's something that I really need a lot, because you always forget how the parameters are called, and you don't want to look in the source all the time. So it's convenient to have that. Also, as I told you, I've reworked the layout, because Stefan, please don't be, no offense, but having the first control inlet conflated with the first audio, the control inlet conflated with the first audio inlet isn't a great idea in every instance. And in this case, I really want to have this one-to-one correspondence. So it makes things more symmetrical, and you have the control stuff separate on the left side, and the rest are simply then the audio inlets and outlets. So I reworked that layout, and that's the main incompatibility. Other than that, there's lots of new messages and stuff which isn't interpreted in PS Faustgen, but otherwise it's pretty much still PS baby, but with lots of new features. So I also tried my hands on a new polyphony scheme. So Stefan now will go into panic mode, because yeah, I want to talk about that tomorrow also in the roundtable session, maybe, because ever since I came up with this frequency gain gate scheme, which is fairly straightforward, and the way to generate different voices from a monophonic synth, which is also convenient, but it has its drawback, because, for instance, you can't do sympathetic strings and stuff like that. And we all know these drawbacks of the scheme if you generate different voices which basically are independent from each other. So I actually followed a new idea here. So I have indexed frequency gain gate parameters. So all the voices are in one Faust program, and you just sum them up. But that opens the possibility that you can have sympathetic strings and similar stuff working in this scheme. And so we see some new metadata, which is almost like the old, but not quite. But I'm going to discuss. Oh, my clock went dark. Let me see how well I'm doing. Oh, I still have half an hour. Yeah, okay. We should be able to finish that in time. So there's the new polyphony scheme, and that brings with it also the possibility to have monophonic synths with old school monophonic legato play and portamento, of course, which is for some styles of music very important. And then the stuff with the PD loader extension, I didn't even have that in PD Faust. So it's now much more convenient. Basically, Faust becomes an external programming language for PD using that loader extension. And I've also added various receivers for wireless communication. So for instance, you can just send a compile message to all the Faustgen 2 objects in your patch and be done with it. You don't have to wire them up or send them to a specific object. You can send them just to all Faustgen 2 objects, and that's very convenient. So these are the main features. You can find some more details about this in the changelog in the GitHub repository. So, and one thing that I had to think about, but I solved that problem long ago for PD Faust, is how to represent MIDI data in PD. Because in PD, MIDI is basically like audio. You have some objects for input and some objects for output. And the different input objects will give you tuples, or you could say separate numeric data for the different kinds of MIDI messages. And this is nice if you want to pipe MIDI data just into a single inlet. You will have to think about a message format which does that. And I've designed something which I call the simple MIDI message format, or SMMF for short, which does just that in a way which is which works nicely with the existing MIDI input and output objects of PD. So the order of the parameters of these messages are the way they are exactly to have this kind of compatibility. And so I have these abstractions which do the conversions from the input objects to these SMMF messages, and also vice versa, SMMF messages to the MIDI output objects. But I won't go into that here. It's very simple to do. You could do these abstractions yourself in just a few minutes. So, but they're there because you'll usually need them, and we'll see them in a minute. So that's the MIDI support, and so the idea there is that you just need a single inlet and you can pass all kinds of MIDI messages to it. Also, for instance, SysEx messages. I don't use that for Faustgen 2 right now, but it's conceivable that instead of tuning via scalar files, you could use MIDI tuning standard messages, which are also SysEx messages, and that would be easy to do because there's support in SMMF for that. Okay, yeah, okay, and now we're getting hands-on. So in case I haven't, you haven't found the links yet, I could maybe switch to the chat and give you a few more links. I need
Michael is asking if the SMMF format is documented somewhere in the web, on the web.
Yes, yes. In the slide, this link there takes you to a web page where there's also some examples there, both in Pure and in Lua, which you can use in PD, but it's also a documentation of the format. The format is very simple, basically what you see in this table here. So let me just switch off the screen sharing for a moment so that I get my chat back. It's crazy. Why can't I just keep the window and project? That's just insane. But okay. So let me.
Albert, do you have some example of this new indexed fragment model you could show?
Yes, we'll go through that in a short while.
Okay.
You'd see some Faust code now,
okay.
Or in the after the next slide maybe. So there we are, and okay, then let me share the screen again. So I left basically the same links you can also find in the slides. If you followed my C file link that I posted earlier, maybe I should repost that once more. So in the slides, you find all this stuff. And if you follow that link, https cfile.rlp.net goes to our cfile instance at the Johannes Gutenberg University. That's on my personal account. And there you find a subdirectory, which you can download as a zip file. Or maybe I should just show to you. Okay, there we go. But links, I need to share the screen. Yeah.
Just to say that all the links are also on permanent display on the IFC website. So don't worry.
Right. I can show you that as well. So here's how this looks like, and you have the slides there. You have my paper there. You have all the examples that. Probably I won't be able to go through all the examples, but the examples that I'll be showing are all there. So let me show this on the website. I think I had that here. Yeah, that's on the teleconferencing website. The last and second last thing here.
Exactly.
You have all the links as well, so you should be able to find this stuff. Okay, so you need either PD or the version that I'm using here, Paradata. You need PD Faustscan 2. And there are packages. I made some Debian and Ubuntu packages on the Open Build service for various different Debian and Ubuntu versions. And you can find Arch packages on the AUR, which is the Arch user repositories. And if you follow the first link, if you follow the first link, then you get to the GitHub page, and then you can just go to the last release, and there you find binaries for Mac and Windows. The Windows binary is only 64-bit. 32-bit doesn't work. I'm not sure whether it's a bug in LLVM or the Faust compiler, but it crashes. In 32-bit, 64-bit version works fine. Excuse me again, I have to get a drink. My voice is getting dry. Okay, I'm back. Voice smooth again, hopefully. So, and you can also find some detailed instructions about how to compile it yourself if you want. Then, depending on the way you downloaded or installed it, excuse me again, the Linux packages will install into a directory which is searched already by PD. But if you download the packages for Mac and Windows, you have to drop it in the contents of the package into a folder which is searched by PD. Your local PD documentation should tell you where that is. On the Mac, I think it's in library PD, or if you're using Paradata, it's in library PDL2org. And on Windows, well, you got to read the instructions in the README on the GitHub page, because I always forget where Windows stores things. I'm not a big Windows user. Okay, then finally, if you want to use it the way that I'm using it here, just put Faustscan 2 tilde into your PD startup libs. So I can show you where that is in Paradata. You have this preferences dialog, and let me pull that over, which looks like this. And you have this startup tab here, and then you can scroll down and put it. Normally, PD Lua is the last external which is loaded by default, and then you just open a new entry and type Faustscan 2 tilde there, and if it's on the path, then it will be loaded. And you can tell that it's loaded if you have something like this sign-on message here, right? So then Faustscan 2 will be available right at startup. You don't have to do it that way, but if you want to make good use of the loader extension, then you should do it that way. So yeah, that's all. Then it's ready to go. Much easier than with PD Faust, which is also one of the reasons why I'm phasing that out, because getting a good part of the pure system compiled and LLVM and all this stuff, that's simply too complicated. Okay, so we've seen the basic workflow. You have a Faust program which you want to run in a patch, so you create the patch and the Faust program in the same directory. or put the Faust program anywhere on your PD search path. And then you can insert either this long form here, FaustScan2 tilde DSP name, or just DSP name, and you can also use the tilde if you want. If you have the loader extension enabled, and that just means that FaustScan2 tilde is already loaded at startup, then you can just type the name of the DSP program without extension and with optionally tilde tagged onto it. So, and as you've seen, once the object is there, you can just click on it or right-click and choose Open. The Open context menu option is supposed to do that as well, and it works in FaustScan2. So then the Faust source of the object will open in the editor, as we've already seen. And to add a PD GUI, a graphical user interface, you create, as you've seen, you create a one-off subpatch. You type PD and then the name of the subpatch, and then you add that name that you used as a name to the FaustScan2 object, and it will be recompiled and create the GUI for you. And that happens every time you load the patch. So if you modify your Faust source offline, so to speak, then you can just open the patch again and it will have the latest GUI. So that's always done automatically. And as we've seen, to recompile a Faust object after edits, you just send it a compile message. And there are a bunch of other arguments and messages, too much to mention them all here. But I'm going to show you some of the stuff, but by no means all of it. There's a good help patch included, which I've expanded from what Pierre made for FaustScan. And you can find all the parameters, all the different messages that it understands, you can find in the help patch somewhere. This help patch has many subpatches, which you should go see so that you have an overview of all the possibilities. So yeah, let's do another example before I go into the subtractive synth example. There we go. Some monosynth action maybe. So just to illustrate how this works, and we can recapitulate the creation process, so the workflow. You start out with, well, the Faust. If you've already written the Faust program, you start out with just including it. In this case, it's in a subdirectory, so I need to type the subdirectory name first, and it's called mono. I can add a tilde if I want. And there's my monosynth. And you see here in the main window, it prints out, it already has a few MIDI control parameters. And it also understands pitch wheel. So I can do pitch bands, and it has one voice polyphony. We see how the polyphony is encoded later on in a minute in the other example. But as you can see, the object, excuse me, the object detects how many voices there are, because they are all in the Faust program. So this one is stereo, as we can see, so I need to hook it up to a deck. Or let's first generate the GUI so that we see what parameters we have. So I'm going to add another subpatch. Same thing as last time. So there's a subpatch opening there. I can close it. And then I just add this here. And now I have the GUI as well. Let me make this a bit bigger so that we see everything. There we are. And I have certain MIDI controls here and of course the possibility to play MIDI into it because it's a synthesizer. So I can place a MIDI input here as I did before and just connect that up, and then we need some audio output. So I need a DAC again and hook that up. There we are, and now I should be able to play this thing. So you see, it's you can do the usual kind of legato play. And I can, I have the portamento parameter I have mapped. If I don't remember, I can just look it up. The portamento parameter is on MIDI controller 5. I have one of these little archaic keyboards here, which has eight endless encoders. So I can just, number 5 is here. So now you hear glissandi. Okay, this all works. So this is the monophonic synth mode, and now we're going to take a look at a more interesting example which does more. So let me close this one. So if you want to follow along, that's the synth.pd example, which is in the examples folder, which I showed you previously. And this is a full-blown example now, so I wouldn't want to enter that interactively, but it consists of pretty much the same pieces, except that we now have also some effects units. And the subtractive synth, which I will show you the source code in a moment. And I have a chorus and a free verb, and the corresponding GUI is over here. And I have an amplifier unit, which is pretty much just, well, amplification, bass and treble control, and balance control. And I also have, for illustration purposes, I've thrown in some dB meters here. So these are passive Faust controls, which you will also see in a minute. So let me get back to the slide to show you the source code. So there we are. Just standard Faust codes. This is not metadata like in other Faust programs which use the polyphonic stuff, because as I said, I'm doing the polyphonic stuff directly in the source code. So they are all 8 voices are here. Therefore, they are summed up here. So there's a sum which goes from 0 to n voices -1, so from 0 to 7 in this case. So I have 8 voices. And for the things that I'm summing here is just voice I. So voice I is defined down here. So each voice is just a sawtooth at a given frequency with a given envelope. Here with a given gain, that's basically the velocity of the note. And I also have the filter here. Of course, the sawtooth first goes through a filter, and that filter has a frequency which is also controlled by the envelope. The envelope is up here. That's just Jan's basic ADSR envelope, which is controlled by the gate signal of the voice number I. So you always have where with normally you'd have just a single voice here in the Faust program. Here you have 8 of them, and they're all indexed basically. Maybe I should first go to the control data. You see that down here in the voice controls, you don't have frequency as one numeric entry or slider or something, but 8 of them, basically. These are implemented as macros. So or no, as functions. So, but you use the %I here to give them different names, right? So they will be named, the frequency I controls will be named frequency 0, frequency 1, and so on. But still, the way that PD Faust2 knows that it's a frequency parameter is this new kind of metadata. I'm just telling it, yeah, this is a frequency parameter of a synthesizer voice. And Faust2 then picks up all these these frequency controls, which are designated as voice frequency, and then it knows how many voices there will be, and it will assign then the same the frequency gain and gate of the different voices by just well, matching up the indices.
Albert,
Yes?
does that mean that the first frec doesn't matter so much? It's the one in the voice metadata that matters?
Yeah, that's the important one, because that's what Faust2 sees, right?
Okay.
It's just like in the old fashion, you have this frequency parameter, but you can name the control variable how you want, but the label needs to be FREQ, right? So that the architecture
sorry.
knows it.
I
right?
mean, okay, in the label here, is it the first frec that matter, or the one after voice?
The I can't draw on here. It's actually, it's this one here, right?
Okay. That was I want.
Yes. Sorry.
Okay,
I was back to the old
yeah, you
bad
were
days.
confused, but,
Well,
I
this
wanted-
is an alternative way of doing it, which allows you to do monophonic polyphony. So you can do legato play and stuff like that, and it allows you to do sympathetic strings and stuff like that, because it's all just in one Faust unit. And I think I should have maybe, when I thought up that frequency gain gate stuff back in the PD Faust days, I regret that now. We should have done it differently. Okay, but anyway, this is an experiment. I don't know whether that's the right way to do it. It seems to work pretty well for me in PD Faust2, so but I still have to implement that in other architectures so that we can give it a go also as VST or LV2 plugins. Okay, but let me come back. So the filter that I have here, this filter is just a Butterworth filter. I took the design from the internets, and you can see that it's a tweaked Butterworth filter by David Werner and Patrice Tarabia. I found on musicdsp.org. And you just see all the filter parameters here, and then the feed forward function, the feedback function, which are in a loop, of course, makeup gain, and that's all. It's very basic, but it sounds pretty good, I think. And then here are the remaining parameters, but we'll see them in a moment anyway. I'm just using, I'll just be using the resonance and cutoff parameters because I want to play around with these, and I take note now that these are on MIDI controller 5 and 6. So, okay. And then there's the amplifier stage, as you might remember. And I have these two passive controls, which are H-bar graphs. And I've mapped these also to MIDI and to OSC. So I'll be demonstrating OSC as well. So we have some OSC controls here too. But in this case, this will be for the passive controls is MIDI data or OSC data, which comes out of the units, out of the Faust modules. So there we are. Let's have a final look at this. And I think then I'm good on time. So first thing, I need some Midi playback. So let me start my Midi playback tool and hook that up. So I'm using on Linux, I'm using this little nice applet here, the drumstick Midi player. So, and of course, you're going to listen to Bach again. And then I need to hook that up to pure data so that we can have some sound. And there we are. And of course, I can now control the volume with this MIDI controller here, and I can control those parameters and diffuse my sound in real time. So, okay, that's one way to go about it. What about if we want to use OC for control, which is of course way more cool than good old MIDI? So let me give you the picture from my this is on my smartphone, and touch OC running on my smartphone, and now I can do the same, but I first need to hook things up a bit because I've not done that automatically, just to illustrate the steps that are needed. I'm using the MR Peach externals here, so which have objects to receive and decode OC, encode it, and send it again. So what I have to do is first to connect to my phone so that I can send OC data back to the interface. I'm going to do that here. So they're connected now. And you see that actually if I move the sliders here now, let's move the volume slider. No, it's not working. Why isn't it working? Maybe it has lost the connection. Let me see whether there's some error message. Yeah, that's always the thing with doing these things live and not in a video. Yeah, it's connecting, so it should be working. Let me see whether the other part of the connection works. That seems to be working, so why isn't the back channel working? Yes, okay. I deliberately made this a separate. Yes, okay. My watch is going off to tell me that I'm about to finish now. So I made this deliberately so that I need to do it manually to illustrate the steps that you take. But of course, you could use load bang and such stuff to set that up automatically. So now you see that this stuff is sent out to the phone as well, and it gets updated automatically by a little subpatch. There's not much magic in there. It uses a /dump message to request the OC output and will send it to the phone. So that's all. Now I can play the music again and control for instance, these parameters. And you also see that the passive controls down there show the volume, the dB meters that you also see over here. So if I just play it once again, doesn't do anything now. Not okay. Now things are starting to go wrong. Jean-Michel, you're not the only one who has stuff not going quite right. It seems that maybe the sound has died. No, it's still going. But everything is working except the MIDI input from my little applet here. So let me launch that again. Or maybe just take the opportunity and show you MIDI playback from Ardor, and then I'll be finished. I might as well do that. So now another possibility, of course, you can use, let me pull PD up in the foreground. Where is it? There it is, and keep that above others. Okay, so I hope that this will work now. No. Okay, auto control is working, but there's
The PD synth is off.
the PD. What is off?
The PD synth, you just turn it off.
Yeah. Have you tried shutting it down and turning it on again? Thanks a lot. Yeah, that was the reason. And now let's listen to another Bach piece, and I can show you some automation. So it's easy to record this stuff into Ardor. In PD Faust, I had a special MIDI OC sequencer applet in PD, which was very simple and very limited. So I've now gone to recording automation in Ardor and just playing it back in the using a MIDI loopback. That works much better than having to implement the sequencer in PD itself, which is always a bit limited. And in the future, that's why I was asking during the Ossia workshop, I actually want to do that with Ossia. But it seems that Ossia might, if I'm using Ossia, I might actually not need that PD anymore at all. So, but I have to see. So, anyway, Stephen, thanks a lot for the remark. This was really throwing off now. Okay, so let's finally take a look at this. So I have some MIDI automation here, which will be played back into the synthesizer, and of course, I could also record that in real time, but my time is running out, so I won't show that now, but I can show you the playback. And I have that hooked up to my X-Touch DAW controller, so I can just start it here. And you could see all the sliders actually moving because they were controlled by MIDI. Of course, it would be much cooler to record OC instead and play that back, because that also gives you better precision. And yeah, so that was about what I wanted to say, to demonstrate. And now I just have one more slide to conclude this presentation.
Don't worry, Albert, we have time. The aperitif is
yes,
only 5,
but
so
then,
you can take time as you like.
But then I can switch, afterwards I can switch screens and follow the chat while I'm also send you my screen via OBS, so that will be easier for me, because right now I can't read any chat, anything that's in the chat, because of the limitations of the Zoom Linux version here. Okay, so to conclude, I think that Faustscan 2 is Faustscan itself also, of course, but this improved version now makes Faust DSP development very easy, because it enables you to run Faust DSPs in PD, which we all know and love. You can edit and test those Faust programs in quick iterations. For developers and musicians, this means that it's ideal for rapid prototyping or live coding. If you want to use it that way on stage. I wouldn't recommend live coding on stage though, because it's easier with other languages than with Faust. You just have to forget one closing bracket. And we've seen how easy these stupid errors are, even forgetting how to turn the synth unit back on. So, okay, for teachers and students, and that's the context that I'm using it in mostly, you can get a taste of interactive Faust DSP development, because you can change it. You could, as a teacher, you can give a program and then tell the students, okay, try this, try that, and then they can become creative and explore the possibilities which are there, using all the stuff that's in the standard library and coming up with their own Faust programs. The PD environment, I think, is very convenient. It's a kind of basic environment, but you can just patch things together, and that makes it very easy to use. I think if OSSIA score has one drawback, then it's complexity. I mean, if you've learned it, then it becomes easy, but anyone can jump into PD. If you learn a few objects, after 1 hour of instruction, maybe you can start working with it. So if you have to think about scores and about time and intervals and all these different concepts, then it becomes more difficult than just having a blank slate on which you can throw some stuff and make some connections. So I think that's a big plus for PD. But OSSIA is obviously a nice contender now, and I'm really impressed in the way it has developed in the past few years. So, but here you have the ability to patch everything together. You can use whatever's available in PD, and you also have the Faust stuff via FaustGen2, and you have easy access to MIDI, OSC, and whatever multimedia devices you have, and have an external for in PD. And when you're done with your Faust DSP, testing it, taking it through its paces, of course, you can just continue using it from PD. And as I've shown, piping Ardor or maybe OSSIA automation into PD. Or you can just take the same DSP code and recompile it and run it in your favorite DAW on another computer, for instance, Reaper maybe, or any kind of environment that you prefer. So some future work that I think I'll need to work on is to explore this new polyphonic concept and see how that how well that works with other environments. So as you probably know, I've written the LV2 and VST architectures for Faust, and I want to rework those to use the same kind of metadata markup that I have in PD FaustGen2. So in order to implement this new polyphony scheme, and I also want to port my Faust MCP, which I've just presented at Linux Audi Conference 2020, which was just last week. Thibaut and Jean-Michel at Bordeaux did that, and that was a great conference as well. And well, Faust MCP is written for PD Faust still, so I still need to port that over to have the Mackie control possibilities with Faust and with FaustGen2 here. So that would be pretty nice as well. If you have one of these Mackie controllers, the problem with Faust is that you have lots of parameters and you want to be able to interact with those, and so you need some kind of device which has a concept of banking and controls, and that's what Faust MCP is for. So I still need to port that over. And that would be it for the presentation. I will now stop sharing my screen so that I can see the chat again. And and interact in a more direct manner. So let me start let me see what I have on OBS.
I have to say it's impressive as usual with Albert.
Let me send you.
thank you
Let
very
me
much.
send you a picture of myself first. Where has it gone? Okay, there we go. So you should be able to see me now.
Yes.
I'm down here. Okay. I can maybe go to another.
And maybe tomorrow we can discuss this new polyphonic scheme and
Yeah,
see how we can, yes.
I'd say that should be something for the roundtable. It's
Yes.
just as I had to implement it all from scratch anyway, I started about thinking, and I wasn't enticed by the job to get all this. I mean, you have to do the voice allocation anyway. You're doing that outside of Faust, but having to manage all the dynamic Faust DSP instances, that wasn't something I was looking forward to. So I went the lazy way and said, okay, why can't I just have all these voices inside one Faust unit? But of course, at some point, we would then need a possibility to shut down some voices and not have them use any CPU.
Yes,
Because that's the downside of this method, because right now, because Faust is always doing all the computation paths, it's a bit, well, all the voices are there all the time if you have them in the Faust source, right?
You probably know we try to work on that with enable primitive,
right.
and
right.
Jan is also working on a new way, a better way to do that with.
I still have his paper
I guess
here on my desktop.
We can have the two parts, the polyphony inside the one DSP, so that you can do, as you said, interaction between voices, but also the fact that you don't want to compute everything all the time. So I guess I'm sure we can find a way to do that. And
yeah, that
will be, obviously it will be better if we can do that inside the DSP itself, and not in the C++ architecture itself.
Right, because one way I imagine that to work is that either you have some way to control the number of voices dynamically from via control parameter. That's the primitive way, but it would also be nice to have possibility to detect when a voice goes beyond, becomes very quiet, and then you can just shut it off and turn it into 0, and then Faust should be able to realize, okay, I don't need to compute that right now.
This is exactly what we can do with the enable feature. That basically, when you reach 0, then you stop the computation. This is the model, basically. Yeah, maybe you can
exactly.
That
would be really great to have. Yeah. So we don't have to discuss it in the roundtable anymore, but maybe about this new scheme and why I did it. I think it makes things much easier also for the architecture implementer.
And also the nice monophonic legato model that we need to have also, because people are asking from. Yes.
Okay, so any other questions? And I'm going to scroll back. Nothing but praise. No bad words. No name calling.
Only good comments.
Yeah, so I don't actually see any questions here.
No, I think
it was all very clear.
Huh?
Pardon?
It was all very clear, so
yes.
no question.
Merci, Jan.
Will it run on Raspberry? Will it run on Raspberry?
Yes, it does.
Yes.
It does. But FaustScan 2, well, Pure Data does. FaustScan 2, I have to work a little bit on it, because right now FaustScan2, the Debian packages I have are only for unstable and testing. And I need to, the problem is that the LLVM version on the stable Debian versions are too old. And we currently need, I think, maybe version 7 because version 9, because older versions won't compile anymore. And that's because we need a fairly recent Faust version, of course, and so it will need a fairly recent LLVM version. And these old Debian versions are still on LLVM6, which is ancient.
Yeah.
Albert, I have a question concerning how you allocate the controller, so to speak, or how do you manage that? Because, for example, if we take the FREC control, so you create your 8 voices, so you have something
Right.
FREC number 3, and then you have the metadata that say it's a voice and a FREC. But then
Right.
the number is in one place and the index is in one place, in a place where the FREC could be replaced by any other name. So
what it does, the number, the order of the controls is also important.
okay.
So it will basically, the way I've implemented it now is that the FaustScan2, when it instantiates the DSP, of course, and then it gets told what metadata is there for the controls. And if it sees something which is labeled voice frequency, it will know that it's a voice, the frequency parameter of a voice, and likewise for gain and gate. And then it has these 3 lists of controls, and it will just make a one-to-one mapping because between them, but they need to be in the same order, so to speak, and that's guaranteed if I just put a %i in here. So it depends on that in a way, not on the particular names, but they need to be ordered in the same order.
So maybe, but this is something we can discuss tomorrow, we could also define a kind of conventional hierarchy of with groups. For example, let's say that you have a group that say this is a polyphonic synth, and inside this group you have a group that say this is voice 1, voice 2, voice 3, and inside voice 3 you have the 3 parameters or whatever parameters.
Yeah, but this will work with this scheme as well, because you could just have a group with the %i in it, voice %i. I could write. Let me pull up that source again. I need to take down the. Okay, let me go to the source. I have it here. Just let me pull that over. Do you see that?
Yes.
I'm in front of it, so I disappeared now. So you should be. I don't know how well you can read that. I can make it bigger, and so.
It's okay.
Is it good?
Yeah, not very, but it's readable.
Okay. Yeah, that's. I could show you the screen again, but then I don't see the chat. So there we are. I could have written something like that: voice, %i, and frequency, and it would work just the same. I just want to make sure that all these are in a one-to-one correspondence, so you don't actually have to have a big logic right in the Faust compiler to deal with those situations, because you already have the ordering by the labels, and that will do the trick. Right.
Yeah. Okay. We need to think about that.
I think it would work just the same. You can use any kind of naming convention that you want. Okay, but I haven't tried it. So you don't have to take my word for it. So.
No. It's yeah.
Okay, I think
There
I've
is
used
another
up all
question.
my time now.
There is a last question.
Right?
I have Stephen asking, I love to run pure data as a audio unit MIDI plugin inside Logic. Is there any perspective on that?
I don't think so right now, because we haven't really lipidified it.
Ah.
So the problem there is that that's a lot of work, because you have to get rid of all the global variables, and we still have those. Miller and friends did that. Did that a while ago already, but we haven't go through that yet. And if no one volunteers for that kind of really arduous task, then it won't happen. So, but of course, you can just use libpd and use your existing patches with that.
I'm wondering, Albert, would that be very difficult to backport the user interface generator that you have in Faust Gen 2 to Faust Gen on Max?
I don't think that Max has the same way of setting up GUIs.
I think Max has a JSON-based format for the patch, and I think it could be possible to generate the GUI as a JSON-based text file.
The problem is,
yeah.
The problem is that I don't know Max well enough. The way I'm doing it here is that it really happens at runtime. So the Faust Gen 2 external generates commands for PD to put objects and connections into a subpatch, and to put a graph and parent area into it. And all that happens at runtime. I don't know whether that's possible in Max.
In Max, what we can do, and we do it a bit, as I explained before, you have JavaScript. So in JavaScript, you can do some kind of dynamic programming to at least to add sliders and buttons in a given patch. So this is the way we do it, even for the Faust to Max static tool that generate a kind of user interface. But right now, I don't know how you can do in a subpatch, but maybe it's possible either by using JavaScript and JSON format in some set. But it probably
the subpatch thing isn't essential. I'm just using the subpatch mechanism because it makes it easy in PD, but you don't have to do that in
So
in
I
Max.
guess it should be possible with JavaScript,
Right?
because we are more or less already doing that, but the code is not so.
Yeah, you just have to integrate it with your recompile step, and then it'll update automatically, and that's all you need.
Yeah.
Right.
So
I see
one has to do that as usual, you know.
Right. It's the infinite to-do list, as I call it.
Yes.
So there was a question: was it Control-C, Control-X? You mean the command that I used to send a compile command to PD? Yes, that was the command that I'm using here, because I'm using the Faust mode for Emacs with the Faust remote extension that I wrote myself, and that binds that command to a certain. Well, it just sends a PD command through a not a pipe, through a socket, and that command gets picked up. Let me see whether I can still find that somewhere. No, but if you want to know more about how this works, just send me an email and I'll explain.
I'm wondering, Albert, if you know, when you use the Faust IDE, it's very easy to have a URL that opens code inside the Faust IDE. So it's super convenient in documentation or when you are teaching Faust to students, for example.
Right.
Could you imagine something similar with PD and FaustGen?
Actually, we've had a Google Summer of Code project this year, which Jonathan still has to integrate, but it's basically working. You can use Pardata in a web browser then. And yeah, I hope that right now it only works locally, but it's conceivable that you can then just share it over the internet.
That was not exactly my question. Is, let's say that you have pure data with FaustGen running.
Right.
It would be a way so that you can, from a text or a kind of URL, open some code inside the PD and doing everything and creating the user interface without having to do that manually. Like in a user can
we could. I mean, you already have that code, right? You're using that with other other projects. We could integrate that. We could integrate the web interface. So just for the Faust units, I thought you were talking about PD in general.
No.
Yeah, that's a good idea. That we should embark on that. Yeah.
Okay.
So I'm not sure what the actual schedule is. Let us see.
Maybe.
So it's time to grab a glass of water.
You must be kidding me.
Yes.
I think we should have at least a short break now so that people can get wine and whatever.
Okay.
Whatever.
Okay, see you later.
Thank you very much.
Thank you, Albert.
Albert, again.
Yeah,
Very
thanks
interesting.
for having me.
Yeah.
Yeah.